So when we look at equivalent fractions, we're basically looking at a proportional equation where there is a multiplying factor that goes either from left to right or right to left. If we're timesing one way by that factor, we can divide by the exact same factor going the other way. And if we times by 5 on top, we have to times by 5 on bottom. If we divide by 5 on bottom, we've got to divide by 5 on top. So they are the directionality of this proportion is important as well, because if we times one way, we're going to divide or do the opposite the other way. And this multiplying dividing factor is always present between proportional equations or equivalent fractions. So here, if I look at this proportion, there is this equivalent proportion going left and right. I can times by 3 going in this direction from right to left, so I can divide by 3 to get a proportional equation, okay, or an equivalent fraction. Now, I've drawn these vertical areas because there are some vertical relationships that exist as well. So this is the easiest one, going from left to right. But there is also a vertical multiplying factor, and I can find that by dividing. Okay, I can find any multiplying factor by dividing. So if I want to find a times factor, I divide. So if I do 12 divided by 3, I get in this direction a times by 4. So if I want to go in the other direction, I'm going to divide by 4. Notice I get the same answer. 4 divided by 4 gives me the 1, which gives me the equivalent fraction to 3/12. So here I'm going to identify, and this is something that I want you to show. For all of these problems, I want you to show the multiplying dividing factor. So, and the directionality of it is important as well. So I want arrows. Here I'm going to have divide by 2. Now, if you want the same answer, it can be found by timesing by 2 like this. But if I'm going times in this direction from right to left, I need to divide left to right. I have to do the opposite because the directionality is important. Okay, so it's going to look like that. I could also just leave it as what I had initially, divide by 2, and as long as my arrows are going the same way and I do the same thing, that's going to be correct. So again, you have to show me these multiplying factors. So this is times 2 here, times 2 here. And again, I find this multiplying factor of 2 by just dividing those two numbers. I can do 3 divided by 6, that gives me 1/2, so I'm going in this direction from right to left. If I do 6 divided by 3, I find the multiplying factor going from left to right. So here I'm going to multiply by 3, so I have to times by 3 here. So 3/8 has an equivalent fraction of 9/24. Okay, again, show me these multiplying factors. You need to indicate these multiplying factors. So there's a times 4 here. Now I'm going in the opposite direction, so I have to divide by 4. And I'm going to check it. 4/12 is the same as 1/3. So same thing here. I'm going to times to the left, so I'm going to divide to the right. So 8/12 is the same as 2/3. Here I have a times by 4, times by 4, and again, make sure that you're writing in these multiplying factors. So 2/3 is the same as 8/12. If you want, you can show this as divide, or you can also do this as multiply by fraction. So I'm going to times by half this way, so I can divide by 1/2 this way. Now this is a bit awkward. Instead of dividing by 1/2, it's much easier to times by 2. Okay, so although this is correct, really it's probably easier to say divide by 2 and then times by 2. Here I have a divide by 6. So I'm going to divide by 6. I can show it as multiplication as well. That's the nice thing about fractions. It's all times and divide, and since times and divide is the same, if I can express it with multiplication, I can also express it with division. So I'm going to divide by 3 here. 16 divided by 2 is times by 8, times by 8. Okay, here I have times by 3. So I'm going to times by 3 to get my denominator of 24. So again, I can just check this: 5 to 8, 15 to 24. It represents the same proportion. So this multiplying factor can show up as, between equivalent fractions like this, but we can also show this as factors or multiplying factors. So I can break down 12 and 15 into 3 times 4 for 12, 3 times 5 for 15. And I can show that a times 3 on the top, so remember that times on top, divide on bottom, so that 3 represents times 3, and divide 3, they undo each other, and leaves me with 4/5. And we know that 12/15 is the same fraction as 4/5. And this multiplying factor, or in this case dividing factor, divide by 3, we can show as factors that cancel out with the times on top, divide on bottom. So this is a different way to do it, but it's showing the same multiplying factors, multiplying or dividing factors. Okay, so I'll give you another example here. So when I have 28 over 12, they share a common factor of 4. So what I'm going to do is I'm going to write it. Instead of 28, I'm going to do 7 times 4, showing the factors. Again, with fractions, we want to deal with times pieces or factors. So factoring is very important in math. 12 can be written as 4 times 3. So these are the same fractions. Since in a fraction, times on top, divide on bottom, and we know that times by 4 and divide by 4 cancel out. As long as it's all times and divide, we can undo times and divide like this. And so this fraction simplifies to 7 over 3. So 28 over 12 is the same as 7/3. There's a divide by 4 factor here, divide by 4 factor here. It can show up as a factor, multiplying factor in the fraction, and we can cancel these factors if we like. So this is the same concept showing up in a different way. So for now, we need to show these multiplying factors. When we get down the road a bit and we want to be a bit more efficient, we don't need to always show that, but we need to show it for now because it's important for you to be able to show me that you understand that these multiplying factors exist, either in this proportional equation in this way, or as multiplying factors that cancel out in a fraction. So there are some examples here and some practice where we can see how these multiplying factors work. And if you click on that link, go to GeoGebra link there, and it will give you some more examples of how this happens.